All right, let's get right into it. We're going to talk about data engineering, the hidden engine that really powers pretty much every modern business. And specifically, we're going to figure out why a language that was born back in the 1970s, SQL, is still the absolute must-have foundation for this entire field.
So it all starts with this problem that literally every company has. I mean, think about it. Every time someone clicks on your website, uses your app, or makes a payment, that all creates data. But this raw data, it's not neat and tidy. It's usually a total mess, incomplete, and scattered across a dozen different systems that don't talk to each other. You've got your payment data over here, your website analytics over there. So the big question is, how do you make any sense of all this chaos?
And this is where our hero steps in, the data engineer. This analogy right here, it's perfect. They're not the ones just analyzing the data. They're the ones building the entire system to manage it. They're the architects, the plumbers, who build the pipes to collect all that valuable water and get it exactly where it needs to go, nice and clean.
So, to put a more formal definition on it, data engineering is all about building these super robust systems that take all that raw, messy data and just tame it. They turn it into a reliable, clean, and accessible resource. And what's the end game? To help a company make way smarter decisions. Everything from figuring out the most popular products to deciding where to build a new warehouse.
Now, the main thing a data engineer builds to make all this happen is something called a data pipeline. And you can think of it as the master blueprint for how data flows through a company.
At its heart, a data pipeline is basically an automated assembly line for data. It's so much better than having someone manually download files and clean up spreadsheets, which, let's be honest, is super slow and just asking for mistakes. The pipeline does it all for you, automatically, reliably, and right on schedule.
And pretty much every pipeline follows three basic steps. First, it extracts data from all those different sources, like your mobile apps or from APIs, which are just ways for different software to talk to each other. Second, it processes that data. This is the cleanup step, fixing errors, getting it all into a standard format. And finally, it loads that freshly cleaned data into its final home, maybe a data warehouse or a dashboard, where it's ready to be used.
Okay, so that process step in the middle, that's where some really important decisions get made. The engineer has to choose exactly how and when to work on the data as it's flowing through those pipes.
The first big choice is all about timing. Are you going to use batch processing, where you collect data for a while and then process it in one big group, like running a sales report at the end of each day? Or do you need stream processing, where data is handled instantly, in real time, the second it's created? A perfect example of that is live fraud detection on your credit card. So yeah, it's kind of like the difference between checking all your email once at night versus reading every single email the moment it hits your inbox.
And the second choice is about the order you do things in. For a long time, the standard was ETL, extract, transform, then load. You clean the data before you put it into your main storage system. But these days, a different way of doing things, ELT, extract, load, transform, is super popular. With this one, you just dump all the raw data into storage first, and then you clean it up after it's already there.
So why the big shift to ELT? Honestly, it comes down to pure, raw power. Modern cloud data warehouses, we're talking about massive systems from companies like Google or Amazon, using tools like Snowflake and BigQuery. They are just so incredibly powerful and cheap now that they can handle gigantic transformation jobs right inside the warehouse. It just makes the whole system a lot more flexible.
So once the data has gone through the pipeline, where does it actually live? Let's take a look at its final destination. Generally, data ends up in one of two places. A data warehouse is built for speed. It stores that clean, structured data that's ready for people to analyze right away. A data lake, on the other hand, is built for just sheer scale. It's like a giant reservoir for all kinds of data. Structured, unstructured, raw, you name it. It's all stored there for some potential future use, maybe for a huge machine learning project down the road. Here's a simpler way to think about it. A data warehouse is like a perfectly organized shelf at the supermarket. Everything's labeled, it's easy to find, and you can grab exactly what you need to get a quick answer. A data lake? That's like the enormous storage room in the back of the store. Yeah, everything is in there somewhere, but you've got to go in, find it, and organize it yourself when you need it.
Okay, so we've covered pipes, processing, storage, but what's the one thing that connects all of these pieces together? What's the one language that this entire system is built on? Well, that brings us to SQL.
To really get why it's so powerful, let's imagine a really simple scenario. Let's say your company has a database, and inside there's a table with all your customer info, their names, emails, and what city they live in. And right next to it, there's a second table. This one has every single order that's ever been placed, the amount, the date, and which customer made the order. The key thing here is that the crucial info is split into two different places.
So now your boss comes over and asks a totally normal business question. Hey, which city is bringing in the most sales? Well, shoot, the customer city is in one table, and the sales amount is in another. How on earth do you connect those two things to get an answer? The answer, of course, is SQL. It stands for Structured Query Language, and it's basically the universal language for talking to databases. It's how you ask questions of your data. It lets you read it, filter it, change it, and most importantly, join different pieces together.
And this is where SQL really shines. A data engineer just writes a simple SQL query to join the customer's table and the orders table together, linking them with something they have in common, like a customer ID. And just like that, you've connected the sales data to the city data, and you have the exact answer you need. It's like magic. And its power goes way, way beyond just joining. SQL is used everywhere in the data pipeline. You use it to read the raw data in the first place, to filter out all the junk, to join tables for complex questions, to transform information into useful formats, and yeah, to create the final reports that the whole business depends on.
Look, if there's one thing to take away from all of this, it's what's right here on this slide. Without SQL, none of this works. It's not just a skill for data engineers. It is the foundational skill. Seriously, if you're thinking about getting into this world, this is square one. It's where you have to start. And let's bring it all the way back to our first analogy. See, SQL isn't just the wrench you use at the very end to get water from the tap. It's also the tool you use to actually design and build the pipes themselves. It's used from the very beginning to the very end.
So, there you have it. That's the basic architecture of modern data. A system of pipelines and storage all built to bring order to chaos, with SQL as its universal language. And that just leaves us with one final thought. Now that you kind of see how it all fits together, what's the first big question you'd want to answer with data?